Okay, then we'll continue the problem. But the difference between this problem and the previous problems, he is not giving the slope of the line. Right? You recognize or not? In this problem, he is not giving the slope of the line. Now, this is the line. This slope is not given, right? Now you want to find first slope of the line such that it is easy for you. Now what is the slope of this line? Change in y-axis by change in x-axis. Now m2 minus m1 by log omega 2 minus log omega 1. Change in y-axis by change in x-axis. Now which is nothing but dm by d log omega is the slope. Now where m2 is 140 minus 20 is change in y-axis, by change in x-axis log 10 minus log 0.1. Therefore, which is nothing but 140 minus 20, 120 by 1 minus of minus 1, which is equal to 120 by 2, which is equal to plus 60 dB per decay. Now this slope of the line slope here it is plus 60 dB per decay. This is now plus 60 dB per decay. But now this line slope is also not given. This line slope is also not given, such that now you find the slope of this line also. Now again, change in y-axis. Now what is the y-axis here? Change 160 minus 140 by change in x-axis log 100 minus log 10. Now 160 minus 140, 20 by 2 minus 1, which is equal to plus 20 dB per decay. Now this is plus 20 dB per decay. This is plus 20 dB per decay. Now see here. Now you can easily, now the question will be the same for the previous problems. Okay. Now you can easily find, now the transfer function g of s. Now these are the corner frequencies omega c1, omega c2, omega c3. Now what is g of s? Now g of s, which is equal to some system gain k, no pole at origin, no zero at origin, because starting slope is 0 dB per decay. Now this is 0 dB per decay, no pole at origin, no zero at origin. Therefore, okay, now this 0 dB per decay will become plus 60. 0 will become plus 60 means the added value is plus 60. Now the plus 60 is because of 0 will become plus 60 means plus 60 is added. Plus 60 is because of, tell me, plus 60 at a corner frequency is because of 3 simple zeros. 1 plus st1 whole cube. Now plus 60 is because of 3 simple zeros. Now this plus 60 plus 60 plus 60 will become plus 20. Plus 60 will become plus 20 by adding. Plus 60 will become plus 20 by adding minus 40. Plus 60 will become plus 20 by adding minus 40. Minus 40 is because of two simple poles. Now plus 20 will become 0 dB per decay. Now plus 20 will become 0 dB per decay by adding minus 20. The minus 20 is because of one simple pole, 1 plus ST3. Therefore, now everything is available. Now the time constant corner frequency is inversely proportional. 1 by 0.1 is 10s whole cube. 1 plus 0.1s whole square. 1 plus 0.01 into s. Now the system gain K. What is the system gain K? Now the starting magnitude is 20 dB. Therefore, the starting magnitude in terms of dB, which is equal to 20 log K base 10, plus or minus, no plus no minus because no pole at origin, no zero at origin, and this starting magnitude in terms of dB is 20 equal to 20 log K base 10, log K base 10 equal to 1. Therefore, K equal to 10 power 1, which is equal to 10. Now this is an ideal transfer function. 3 poles, 3 zeros. Final slope is 0 dB per decay. Now in the given Bode plot is also 0 dB per decay. Sometimes in the problems he is not given the slope of the line. This is the way you can find the slope of the line and get back the transfer function. Okay, note down this. Now we solve classroom workbook problems. Bode plot classroom workbook problems. Now I hope you have some idea of the Bode plot, and if you do a little bit practice and you are in a stage of without finding that diagram and without drawing the diagram, and you can easily get the answers from the options. Okay, now in our classroom workbook, question number 1, what is given? A system has 12 finite poles. A system has 12 finite poles and 2 finite zeros. A system has 12 finite poles and 2 finite zeros. What is the question? Its high frequency Bode magnitude flat slope is dash. Okay. A system has 12 finite poles and 2 finite zeros. What he is asking is its high frequency Bode magnitude flat slope is dash. Options are given: minus 200 dB per decay, minus 40 dB per decay, minus 240 dB per decay, minus 320 dB per decay. Now you understand the question. Its high frequency. Its high frequency means last frequency. Its high frequency Bode magnitude flat slope is nothing but the final slope. Indirectly, the last frequency slope is nothing but final slope. Okay. So the final slope, its high frequency Bode magnitude flat slope is nothing but final slope 12 finite poles and 2 finite zeros, now multiplied with minus 20 dB per decay, now which is nothing but 12 minus 2, 10 into minus 20, minus 200 dB per decay. This is the final slope. Minus 200, minus 40, minus 240, minus 360 is given, and the answer is its high frequency Bode magnitude flat slope is nothing but a final slope. Okay. Now this is question number 1 in our classroom workbook. Take down this. Okay. Now a classroom workbook question number 2. Our classroom workbook handout question number 2. The Bode flat as shown in the figure below. The Bode flat as shown in the figure below. Now the Bode flat is given to you. Now this is the Bode flat which is given. Now by considering the following Bode flat, the transfer function consisting of, by considering the following Bode flat, the transfer function consisting of, options are given. These are the options: 1 pole 1 0, 2 poles 1 0, 1 pole 2 0, and none of the above. Okay. Now its corresponding transfer function is consisting what? Is having a pole, is having a zero, is having both, is having how many poles, is having how many zeros, like that he is asking. Very simple question. Now the starting magnitude is the starting slope is 0 dB per decay. Now 0 dB per decay will become plus 40. 0 will become plus 40 means the added value is plus 40. Who will produce plus 40? The plus 40 is given by 2 finite zeros. Is it right or not? Because at a corner frequency. Next, plus 40 plus 40 plus 40 will become plus 20. Plus 40 will become plus 20 by adding. Plus 40 will become plus 20 by adding minus 20. Plus 40 will become plus 20 by adding minus 20. Now minus 20 is given by 1 finite pole. So now the transfer function consisting of 1 pole and 2 zeros. Is there a 1 pole and 2 zero option is there? Now that is option number C. Note down. Okay, now we'll see classroom workbook question number 3. Now in our classroom workbook handout, here is also the Bode plot is given. Now see here, now your classroom workbook question number 3, the Bode plot of a transfer function is dash, and these are the options which is given to you. Now what I am asking is, now don't convert into time constant form and all these things, you don't do it, just a little bit analysis you have to do it, and just an idea, and such that you can get which one of the following is the correct option. Okay, now one thing is clear, that what is the starting slope? The starting slope is -20. -20 is because of one pole at origin, must and should. So here there is no one pole at origin, wrong. Here there is no one pole at origin, wrong. Here there is no one pole at origin, wrong. 100%. Now one pole at origin is only one option. Then don't touch anything. Okay, clear or not? And otherwise you have any other things. No sir, I want some confirmation. Now what is the final slope? The final slope is 20 dB per decade. Am I not? So you already identify that option is correct. You check that is a 20 dB per decade or not. Now how many poles? Only one pole, but there are two zeros. So what is the final slope? Zeros are more. Nz minus Np multiplied with plus 20 dB per decade is the final slope. Now two zeros, one pole multiplied with plus 20, therefore plus 20 dB per decade is the final slope. Is matching or not? Again it is matching. This is the ideal transfer function, will not make a final slope 0. This is 0, wrong. And this is 2 poles 1 0, that is also wrong. Now without touch a pen on a paper, like that you can find the answer within how much time you will take this one to get the correct option. Tell me. No time constant form, no corner frequency, no system gain, all these things are not required. See that simple logic and you can get the answer. Okay, option A is correct. Okay, now question number 4. Now in our classroom workbook handout, question number 4. Again a Bode plot is given, but this is for 2 marks in the previous GATE examination. What he is given, which is very important and interesting question also. Question number 4. A Bode plot is given. Now this is classroom workbook question number 4. Now this is the transfer function is given, and what he is asking is, by considering the following Bode plot, what is the steady state error for unit step input? Now you understand, he is asking what is the steady state error for unit step input. Now for finding the steady state error, first I need the open loop transfer function. Now what is the open loop transfer function? Now here corner frequency is also not given, not required sometimes. Now this is 0 dB per decay. Now what is the transfer function? G of S, which is equal to K. Is there any pole set origin? Is there any zero set origin? No. How you can say? Because the starting slope is 0 dB per decay. No pole at origin, no zero at origin. 0 dB per decay will become minus 20. Now 0 will become minus 20 by adding one simple pole. 0 will become minus 20 means minus 20. 1 plus ST1. This is K by 1 plus ST1. Now which is nothing but K by, sir, corner frequency is not given, sometimes is not required. Now I want to find K, system gain K. No pole at origin, no zero at origin. Therefore, the starting magnitude in terms of dB, which is equal to 20 log K base 10. So the starting magnitude is 40 dB, which is equal to 20 log K base 10. 40 by 20, which is equal to 2 log K base 10, which is equal to K equal to 10 power 2, which is equal to 100. 100 by 1 plus ST1 is the transfer function, right? Now this is the transfer function. There is no pole at origin. Therefore, this is type 0. Now the transfer function G of S, which is equal to 100 by 1 plus ST1. Now this is type 0 system, because for finding the steady state error, because steady state error depends upon type of the system. Is it right or not? The steady state error depends upon type of the system. And for unit step input, which input? Unit step input. Unit step input is given R of t, which is equal to U of t, which is equal to 1, which is nothing but t power 0. You have one shortcut method. Type is 0. Power is also 0. Type and power both are same. Then what is the steady state error? The steady state error, this is a special case, A by 1 plus K. If you remember or not, unit means A value is 1. 1 divided by 1 plus K. While calculating K, there is a shortcut method. The numerator constants by denominator constants of the open loop transfer function. Numerator constant in place of K, numerator constant is 100 by denominator constant is S tends to 0 means this is 0, 100 by 1. Numerator constant by denominator constant is a K. Therefore, the steady state error, which is equal to 1 by 100 plus 1, 101. And some of the students are missing, then type and power are same, A by K. A by K. Yes, type and power are same, A by K. I am also agreed. Type 1 power 1, A by K. Type 2 power 2, A by K. Type 3 power 3, A by K. Type 100 power 100, A by K. Such that most of you are thinking that type 0 power 0, A by K, A by K, A value is 1, 1 by K, K is 100, 1 by 100. Now students, that option also there. 1 by 100 is also there in the option. Most of the students are going for that one. That is wrong. This is a special case when type 0 power 0, A by 1 plus K. Now therefore 1 plus 100, 101 is option C. And option D is 1 by 100. That is the wrong option. Okay. Now this is question number 4 in our handout, classroom workbook handout. No doubt. Okay. Now your classroom workbook question number 5. This is very. Now he is linked Bode plot with the steady state error, because from the Bode plot we want to find the transfer function, and that transfer function we can utilize in the steady state error. Now question number 5 is again a Bode plot diagram is given. But this is another kind. Sir, in this question, now see, now in question number 5 is Bode plot is given and he is asking what is transfer function. So here the problem, if you observed or not, starting magnitude is not given. Okay, starting magnitude is not given, but if you observed or not, the plot is crosses the 0 dB line. Now there some frequency is mentioned. Okay, the plot is crosses the 0 dB line. There he mentioned some frequency, but most of the students are thinking that this 4 radians per second is a corner frequency. Is a corner frequency? No, that is not the corner frequency. Corner frequency is the frequency the slope changes from one level to another level. Yet 4 radians per second, it should be on the same minus 40 dB per decay line. So here to here, this is minus 40 dB per decay line. This is not the corner frequency. Maybe saying that this may be a crossover frequency, because at this particular frequency, now it will crosses the 0 dB line. Am I right? Not? It crosses the 0 dB line. Anyway, we will try to find out that. Now the transfer function g of s, which is equal to some system gain k, I don't know. Now the starting slope is minus 40 dB per decay. The starting slope is minus 40 dB per decay means 2 poles at origin, k by s square. Again, minus 40 will become minus 60 at a particular corner frequency. Minus 40 will become minus 60 at a particular corner frequency. Therefore, the added value is minus 20. Now, minus 20 is because of one simple pole, 1 plus st1. Now, this is omega c1 corner frequency. Therefore, now the time constant and corner frequency is inversely proportional, k by s square into 1 plus omega c1 is 10. Now 0.1 into s. Therefore, now the system gain k. Now the system gain k is the problem here to find. So you know that what is the magnitude. So we know that k by the starting, because we know that the magnitude formula is what? Can I write like this? The starting magnitude formula in terms of dB is, the starting magnitude formula in terms of dB is 20 log k base 10 plus or minus. Here there is 2 poles at origin. Therefore, minus into 2 into 20 log omega base 10. Therefore, now the starting magnitude in terms of dB, this is 20 log k base 10 minus, because he is not given the starting magnitude here. I don't know the starting magnitude, but I know at this particular frequency I can utilize this. At this particular frequency then the magnitude is 0 dB. So when I use this frequency of 4 radians per second, now this magnitude will be treated as 0 dB, because at 4 radians per second the magnitude is 0 dB. So which means that this is 0 dB, which is equal to 20 log k base 10 minus 20 log 4 square base 10. Therefore 0 dB, which is equal to 20 log k by 4 square, k by 16 base 10. Therefore which is equal to k by 16, which is equal to, now 0 by 20, 0, 10 power 0, now 10 power 0, which is equal to 1. Therefore k equal to 16, system gain k equal to 16, because this is omega square, or you may write like this also, okay, it's not a problem. M equal to k by omega square, because you know that k by s square, k by s square. Now this is k, I don't know. Now this is s square. By using that, now k by s square will be crossing at a one particular frequency of 4 radians per second. There the magnitude is 0 dB. So therefore this is nothing but 16 by s square into 1 plus 0.1 into s. In the time constant form, in a pole 0 form is s square into s plus 10. Okay, note on this. Okay. Now your classroom workbook, question number 6. Is again a Bode plot which is given to you. Now this is the Bode plot which is given to you. Now what he is asking is, for the Bode plot, all the poles and zeros are real. For the Bode plot, all the poles and zeros are real. Then he is asking to find the difference between FH and FL. FH minus FL in terms of hedges is dash. That is the question. All the poles and zeros are real part. FH minus FL in terms of hedges is what? He is asking. Very simple. Now he is given the slope of the line. We will take this one. Okay. Now this is nothing but, see, x comma y. Am I not? Now what is this? X is log. This is logarithmic frequencies, log scale. FL comma 0. Now what about this? This is nothing but 300, right? So this is 300 comma 40 dB. Am I right? Now this is 300, sorry, log 300. Log 300 comma 40. Now and this line slope is also given, then you will find here. Now x1, y1, x2, y2, y2 minus y1, 40 minus 0 by x2 minus x1, log 300 minus log FL. Change in y-axis by change in x-axis, and the slope is plus 40. Change in y-axis by change in x-axis. Now this is nothing but 40 cancel, log 300 base 10 minus log FL base 10, which is equal to 1. Therefore log 300 by F, which is equal to log, this is 40 cancel, which is equal to 1. So 300 by F, sorry, F not, this is not F, F is FL. 300 by FL, 300 by FL, which is equal to 10 power 1. So FL is nothing but 300 by 10, FL equal to 30 Hz finally. Now similarly, can you find for that one also? Now this is log 900 comma 0, and this is log FH comma 40. Now similarly, if you find for that, now x1, y1, x2, y2, y2 minus y1, 40 minus 0, y2 minus y1 by x2 minus x1, log FH base 10 minus log 900 base 10, y2 minus y1 by x2 minus x1, now which is equal to minus 40 dB per decay. So minus 40 cancel, log FH minus log 900, which is equal to minus 1. Therefore log FH by 900, which is equal to minus 1. So FH by 900 equal to 10 power minus 1. This is minus 40 dB per decay, Fh by 900, which is equal to minus 1, Fh by 900, 10 power minus 1, which is equal to 0.1. So Fh, which is equal to 90. Note down that. Now here I think you will take, this is x1, y1, x2, y2. Now y2 minus y1 by x2 minus x1. But this is the falling slope, so we should be taking as a negative slope is the minus 40 dB per decay. Okay, but this is the falling slope. Now this is falling slope minus 40 dB per decay, and this is a change in y-axis. Now this is 40 minus 0. If I take like this 40 minus 0, because this is minus 40 dB per decay, therefore I can take reverse. Okay, now I'll take this one x1 and this is x1 y1 x2 y2. Then what should be the small change? The small change here, because that is falling slope, so this is nothing but y2 minus y1, 0 minus 40 by x2 minus x1, log 900 minus log fh, which is equal to minus 40. So that minus minus cancel, therefore log 900 by fh, which is equal to 1 minus 1 minus minus cancel, which is equal to 1. 900 by fh, which is equal to 10 power 0. Sorry, 10 power 1. So fh, which is equal to 90 hedges, or whatever it may be.